while we're talking about the sensible heat equation, I want to show you 4 ways to use it. The first way is to find your heat transfer capacity. In other words, maybe the sensible load on a coil. So in this scenario, we know what T1 is, and we know we need 55-degree leaving, and we want 1,000 CFM of that, which means CFM and delta T is known, and we just have to solve for Q. Pretty straightforward. Q equals 1.1 times 1,000 times 100 minus 55. Voila, we've got 49,500 BTUs, sensible load. Scenario number 2 is we can use this equation to find the required CFM to accomplish a desired heat transfer. So in this scenario, we know what the sensible load is inside a space, we know the temperature we want, the T1, we know the temperature we can achieve, and we need to determine what the CFM is. In other words, if we know the space sensible load, then we can use this equation to determine the required design CFM for supply air. And here, I've rearranged the equation so that we're solving for CFM instead of heat transfer. So now I just have to fill in my knowns. 5,000 divided by 1.1 times 72 minus 55. And crunching these numbers, we get 267 CFM. Call it 270 for the space. Okay. Scenario number 3, we're just solving for different variables here. In this one, you need to find the required discharge air temp given a set CFM. So again, we know what the sensible load is in the space, we know the temperature we want, but we're limited to 300 CFM. Now we need to determine what the discharge temperature needs to be at that flow rate to satisfy this space sensible load. Here again, I've rearranged the formula so that we are solving for T2. And if we crunch these numbers, we get 56.8 degrees Fahrenheit. So about 57 degrees Fahrenheit at 300 CFM will satisfy this space sensible load. Awesome. Okay, scenario number 4, we need to find the maintainable set point given a set discharge temp and a set CFM. So maybe your system is limited to a certain capacity and you need to determine if the space sensible is 5,000 BTUs, what set point can you maintain given 300 CFM at 60 degrees. So I have again rearranged the formula, and this time we're solving for T1, and to crunch this, we get 75.2 degrees Fahrenheit. So maybe you need to inform somebody, hey, given this system, we're only able to maintain 75 degrees Fahrenheit in this space. So those are 4 different scenarios where this equation comes in handy. If you guys have any other favorite use cases for the sensible heat equation, I would love to hear them.